In this application, we're going to be using the Acuity AP820-5 laser line sensor. And here that model is. And so what that means, it has a 5mm depth of field in the Z direction, and we're roughly going to have a 4mm wide laser line sensor. And with this model, we should have a linearity of about plus or minus, let's say, 3.5 microns of accuracy. In the X width, if this, typically if we're looking at a surface like this of, let's say, 4mm, we would divide that by 580 points. And so we should have a pixel roughly a little bit better than every 7 microns. So worst case, just raw data in X, we should be able to hold plus or minus 14 microns, I would think, in X for the thickness. And so here you can see we've got this little DEM mounted up, and we're looking across it with a red laser line. My fixture's not the best, just using some modeling clay to try to get it as straight as possible. And here you can see is that profile that the laser's providing. And interestingly enough, this is the printed circuit board epoxy material down here. And here you can see where it appears to have been routed. And this appears to be part of the gold contact area. So we are seeing some of the offset, and this is probably a little a trace here that we're picking up as it's coming straight down. We could probably get a little bit better signal if we had much more robust fixturing. And as you can see, as I move that, you can see that we are getting those measurements. It's actually trying to pick up some of the other smaller features here on the. It looks like some sort of small little electronics parts that we're picking up. But the main thing here is to show that we can make that thickness measurement, and we actually do have some tools that we can use with this Acuity View software, where if we want to measure the thickness of that, and if we want to go for feature 1, we would pick the left edge, and feature 2, we would pick the right edge. And so what it's doing is it's putting it's out there, it's measuring it. It is showing about 1.1 millimeters, and I did hand mic it, and that is approximately within probably 10 microns of where we're at. It's sort of hard to tell with a hand mic because of the compression. But as you can see, as I move that, we're making these measurements real time on that part. So we're not going to have any problem with that epoxy glass or the gold surfaces. And let me just clear some of this. So now we're back to just looking at the profile. With this software, we do have the capability of doing some 3D scans, so you can collect more data doing that also if you'd like. And here you can see I'm just running that encoder over it, and it is picking up that data pretty good. So let's go ahead and clear this, and we'll just do some real rough sort of points. And as you can see, as I'm kind of going slowly over that, picking up using our encoder to get a lot of data. And if we look at this in static points, there's that edge of this part. And here you can see there's the notch that's been cut out. And here, let's see if we can zoom this up enough to where you can see some of the small features of that material on that gold contact that's been, looks like beveled or routed out there. So with this sort of technology, you should be able to scan as you've seen here. And let's just clear that. And you can kind of get an idea for speed of us being able to do that. So I would say 10-15 seconds easily we can scan the whole part like that and give you a 3D model of that edge.